So 5.3, trig functions of any angle. It's a little review of SOHCAHTOA, and it is very helpful to have the unit circle nearby. So 3 sets of problems we'll look at today. The first set, they're actually a fair amount of work. Find the exact value of each of the 6 trig functions of theta if this point is on the terminal side. So basically, these are just plotting each of the points and then identifying sine, cosine, tangent, but then also reminding us and reviewing cosecant, secant, and cotangent. So for something like number 1, if I have a point -4, 3, think of this in terms of the xy axis. Go left 4 and up 3, and this then creates the angle. And so I have sines of 3, and that -4, it's not the length of the triangle, but when I think in terms of sine, cosine, and tangent and what's positive, what's negative where, that's where I have to be on the lookout. So I need the hypotenuse, though, if I'm going to find something like sine and cosine. All I could find right now would be my tangent. So if I take 3 squared, and again, think of this, if you want to think of it as -4 quantity squared to get that hypotenuse, which we'll call C. Thinking back to the Pythagorean theorem, that's fine, but really it's going to end up being a positive number anyways. So C squared is going to be equal to 9 plus 16, which is 25. So my hypotenuse has to be 5 here. So my angle that I'm working with, zoom in a little, is right here where it meets the axis. So imagine that that says theta and doesn't look like just a little tiny blob that's there. So my sine of theta, the opposite side is the 3, so it's 3/5. The cosine of theta, adjacent over hypotenuse. My adjacent side is my 4, but that's a -4 because I went left. So anything in the second quadrant, the cosine is going to be negative. Tangent is opposite over adjacent. And so 3/-4. So same thing. Remember that the sine is essentially the y-coordinate. Cosine is the x-coordinate. So in terms of positives and negatives and where all these things fall out, the y is positive above the x-axis. So in quadrants 1 and 2, that means sine is positive there. Cosine is positive to the right. We're on a point over to the left. So if the cosine is negative, then the ratio of those two things must then also be negative, a positive divided by a negative. And then once I have those, figured out, my cosecant is just the reciprocal of the sine, so 5/3. Secant of theta is the reciprocal of the cosine, so it stays negative, -5/4. And then cotangent is the reciprocal of tangent, which is -4/3. So again, a lot of this is just reviewing when we first started SOHCAHTOA and looked at a right triangle and used Pythagorean theorem to find the missing side. It's just a matter now of recognizing that it can be positive or negative dependent upon where it falls. And when we initially did them, they were all essentially quadrant 1 problems, which is the difference. And so if we take a look, maybe at something like number 5, where it gets a little bit messier. If I have 3, -3, then I'm going to be down here in the 4th quadrant. So if I go right 3, down 3, this does make a nice little isosceles right triangle for me. 3 and -3, so 3 squared plus my -3 squared. And this again goes back to the isosceles right triangles. And so 9 plus 9 is 18. If I think of the square root of 18, we've done this a couple of different ways. If we think of what is a factor of 18 that's also a perfect square, I can split this into 9 and 2. I'm always going to be able to split these into 9 and 2 because it's isosceles. They're always going to have 2 parts that are the same. So C is actually 3 square roots of 2, which you might also remember from geometry. as being the relationship in a 45, 45, 90 triangle. So here again, I'm looking at my angle theta. And so the -3 is my opposite side, and the +3 is my adjacent side. And then the 3 square roots of 2 is my hypotenuse. So my sine of theta is opposite over hypotenuse. And we should simplify this. We shouldn't have a radical in the denominator, but that's not the focus of what we're doing, so I'm not too worried about that today. The cosine of theta would be the +3 over 3 square roots of 2, and then tangent theta is going to be opposite over adjacent. So -3 over 3 just becomes +1. And then same thing, my cosecant of theta is the reciprocal. I didn't simplify those, and I should have. Hold up. I have 3 divided by 3, which is really just -1 over the square root of 2. Those simplify. And then the same thing happens here, but it's +1 over the square root of 2. Cosecant would be the reciprocal. So negative square roots of 2 over 1 is just negative square roots of 2. It's messy. Secant of theta would end up being the positive square roots of 2. And then cotangent theta would just be a +1 because the reciprocal of 1 is simply 1. So for all of these problems 1 through 8, they again are a fantastic review of all things unit circle and SOHCAHTOA related for where they fall. So more unit circle to come here in problems like 9 through 16. So evaluating these very special angles. So as a reminder, on my unit circle, I had 0 or 360 degrees here, and that was the same thing as 2 pi. And so remembering that these are in radians, this would be my 90 degrees, my 180 degrees, my 270 degrees. But again, in radians, 180 was the same thing as pi. If a full circle is 2 pi, then half a circle is pi. And then half of a half is my 90. This becomes pi over 2. And then 3 pi over 2 at 270. And so if I'm thinking of my coordinates as x comma y being cosine comma sine, then this point here, I'm going right 1, and I have a height of 0. Here, I'm going up 1. I have no left or right. If I go left, then I go left, -1, 0, and then down is 0, -1. So while I'm working through these problems, if I have just that component of the unit circle, I can knock a lot of these out. The cosine at pi would just be the x coordinate. This is simply -1. And then for tangent, we have to remember that tangent is the ratio between sine and cosine. Squeeze my thetas in there. So the tangent of theta is really just sine over cosine, which is y over x. So this is where we can end up with a few things being undefined. So the tangent at pi, y over x, would be 0 over -1. So life is good, that's equal to 0. I'm going to do my other 2 tangents right now. The tangent at 3 pi over 2 for number 13, y over x would be -1 over 0, which is where this is undefined. And then the tangent at pi over 2, the same thing happens. It's just +1 over 0, which I can't have. And so that is also undefined. Reminders of my others here, and I just have one of each. Secant is the reciprocal of the cosine. And so at pi, the cosine of pi would be -1. So the reciprocal of that would be 1 over -1. And it seems silly, but it just simplifies to -1. For number 12, my cosecant reminder is that that is 1 over the sine of theta. And so pi, the sine of pi would be 0 because that's the y coordinate. So this becomes 1 over 0 And so this is another instance where it's undefined. I skipped the cosine of 3 pi over 2. That's just the x coordinate. That's 0. And something like the cotangent at pi over 2. So reminder on that guy that the cotangent, the cotangent of an angle is the reciprocal of the tangent. And so this time I'd be looking at x over y instead of y over x, if that one is a little bit easier. So 0 over 1 is just 0. So for all of those, it's either 0, it's positive 1, it's negative 1, or we end up with it being undefined. And that happens on those 90-degree increments, so 90, 180, 270, 360, or thinking of it in terms of pi over 2, 2 pi over 2 is pi, 3 pi over 2, and then 4 pi over 2 would be a full circle because 4 pi over 2 is the same thing as 2 pi. So last but not least, and these are some of my favorites for whatever reason, name the quadrant that the angle ends up in. And so recognizing when these values are positive and when they are negative. So I like these, I think, because I like to draw them. So the sine of theta is going to be greater than 0. That's just fancy for saying that it's positive. Cosine also being positive. Less than 0 we'll take a look at. So this is when we have a negative positive combo. So the sine of theta is positive here and here, because that's when the y-coordinate's positive. Cosine is positive to the right of the axis. So the cosine is positive in quadrants 1 and 4, where the sine was positive in quadrants 1 and 2. So when both are satisfied, the quadrant where this angle would be has to be quadrant 1 is the winner, because that's really just where the overlap is. That's where both of these things happened that I'm agreeing to. So sine and cosine again for 18 and 19. So let's try something like number 20 with a reminder about some of these. So the tangent being negative. If I know that cosine is positive here and the sine is positive here in quadrant 1, then whenever I divide those two to get the tangent, it also has to be positive. So whenever one of them is negative, like in quadrant 2, the tangent has to be negative. In quadrant 3, I end up with 2 negatives being divided, so I end up with tangent being positive again, and then my positives, negatives here. So sine and cosine, we can remember sine is like y, so it's positive above, negative below. Cosine is like x, it's positive to the right, negative to the left. Tangent is the ratio, so tangent's in opposite quadrants. So in 1 and 3, it's positive, but in 2 and 4, it's negative. So the tangent would be negative here and here in 2 and 4. And then the sine is negative in quadrants 3 and 4. So where they meet up to chill out is in quadrant 4. And so my answer would be quadrant 4. So just a little visual, a picture, just to see what's happening with these. And this, again, this first part of section 5.3 in our textbook, where we're talking about just trig functions of any angle, it pulls together a lot. And this, if we're solid with SOHCAHTOA and we're comfortable with that unit circle, should work really well. And so if parts of this need to be paused and rewatched and rewatched and rewatched and rewatched, have those resources and notes in front of you. I think it would help an awful lot.